You're looking at the world's largest airplane rolling out at the Mojave Air and Spaceport, clocking its fastest taxi time yet at about 74 kilometers per hour. This is a milestone for this giant, soon-to-be flying beast. This gets us one step closer to actual flight test when they'll need to get up to probably about twice the speed, 150 kilometers per hour. Paul Allen developed Stratolaunch in order to build a vehicle that will take rockets up to nearly the stratosphere and launch them into space. Allen's original vision was to launch a relatively big rocket in the class of a SpaceX Falcon 9, but because they don't have a rocket designed for that horizontal launch in that class, they're going to be launching up to 3 small rockets at a time. This aircraft is massive. It has 6 engines that were removed from 2 used 747s. Its wingspan is so big that if we dropped it in at our Coliseum football field over here, the wings would hang over the edge of the facility. It's got this big empty space in the center, and you can put a big rocket there, but you could also put a massive customized container. You can carry a payload with optical telescopes. There's a lot of different things you can do with that big space between the 2 fuselages. Since then, Stratolaunch has conducted an engine test where they tested each of the Pratt & Whitney engines incrementally to make sure that they were performing. These are flight proven on existing 747s that they were removed from. So they're testing not just the engines, but the engine mounting, the fuel supply systems, and everything involved in the control mechanism. At the end of the year, they capped it off with an actual taxi test where they tested out the brake systems, the hydraulics, and some of the control systems that will be necessary to move the plane on the ground and, importantly, make sure that it can land safely. This latest test updates that have been done to the system. In particular, they're testing the braking systems, they're testing the hydraulics on the control surfaces, they're testing the effect of the design under a decent airflow across the air surfaces. By moving the plane quickly through the air and adjusting the control surfaces, they can begin to see how some of the response is. They can feed all of this data into their digital flight control systems that they use both for the plane and, importantly, for the simulators that the pilots that will be trained to fly the vehicle can use, because this vehicle is of a class that's never been flown before. There is no training program, and you need a very accurate simulator. Looking at what they're doing now on the ground, I would expect that we may see this vehicle take off by the end of the year or next year. I think there's a great deal of promise for this idea of launching rockets from above the atmosphere, anytime at any orbital inclination. This gives incredible flexibility to potential future human spaceflight.